Welcome. This talk is about adaptation of business rule in workflow systems. It is part of recent completed PhD research at London Metropolitan University, prepared and presented by Kanana Ezekiel. The talk plans to give an overview of the following topics: the background of research problem, research questions or hypotheses, methodology used, our results or research contribution, validation methods used, and finally conclude with recommendations for future research topics covering the limitation found in this research. Background or research problem. Creating workflows seems to be a very simple task, at least at the beginning. When workflow policies and rules change, users will face many configuration issues, as highlighted in our 2019 published journal. This caused major roadblocks in managing and maintenance of workflow despite many benefits they bring. Just as an example to the right is an article published May 2019 concerning risks introduced by workflow disruption, which are caused by configuration challenges. Usually as a result of disconnect between workflow design and business processes, arise due to new process being introduced or business requirement change. Note, for healthcare professionals, the stakes are much higher. Besides productivity losses, there is a huge risk to patients in form of improper care. Workflow issues may lead to medical errors, the third leading cause of death in the United States. Hence, the need for configurable workflow have been discussed and well documented by various authors, including Gregory Harrison, Abdullah Raza, to name the few. This research is concerned with adaptation of business rules to manage and support workflow configuration and automation. When business rules are added, modified, and interrelations are established, business rules will require extensive work to maintain their consistency in workflows. Development of business rule framework or formalization is necessary to provide business rule structure and language. In addition, business rule adaptation algorithms to manage workflow functionalities such as start, stop, and execution of processes have been developed. In workflow, another important element is the degree to which business rules can quickly change and propagate their changes in real time. Hence, this research developed business rule indexing and change propagation algorithms. Here are key questions which present the scientific significance of this research. First, what factor cause configuration issues or limit the adaptation of business rule in workflow? One difficulty is the lack of consistent model or language to manage rules at component level, event, condition, action. Second, how can we develop an ontology of business rule workflow which allow to formalize business rule using templates so that dependence can be described? This research has defined concepts and structures which include event, condition, action, as well as introduced two-level conceptual framework. Furthermore, and/or graphs to manage complex relations. Third, how can we create efficient methods for change propagations to enable runtime adaptation and retrieval of business rule in workflow? This research implemented dependency graph patterns combined with indexing and change propagation algorithms. Fourth, how can we optimize business rule to provide runtime modification? A meta-rule concept was introduced to support runtime modification of business rule. Fifth, how can we enable adaptation of business rule to control workflows in real time with reasonable complexity? The adaptation algorithms have been implemented to enable basic functionalities such as start and stop processes as well as executing sequential and parallel process flows. 6. Can the proposed model structure be able to generalize new business rules in workflow not seen during prototype validation? The implementation of business rule component classes and rule templates provide generic, reusable, and adaptable objects that can change at runtime. Research methodology. The approach taken to reach our research goal combines three main methods. First, analytical methods. Analyze necessary activities to provide a rich set of business rules. Business rules acquisition, business rule preparation and classification. Second, constructive methods. Business rule model development, business rule model optimization, deployment and productization responsible for creating framework to meet real-world conditions. Third, experimental method, which is validation of the prototype. Research contributions. For workflow configuration problem, we provide multi-layered system architecture with a clear separation of processes ontology, rule policies, and meta rules. For creation, modification, and deletion of business rule at component level, we provide a conceptual model for rule adaptation based on incremental propagation of changes across the network of interrelated business rules. For business rule change propagation problem, we provide the incremental algorithm for change propagation, which uses the and/or graph and results in actual adaptation. In addition, we provide meta rule concepts to support runtime modification of business rules. For business rule component relationship problem, we provide an algorithm for semantic indexing of business rule, which accounts for their structure and results in the and/or graph dependency. The outcome of this research provides not only a rich set of business rule constructs, but also an enhanced and efficient mechanism to allow workflow to be easily modified. Validation methods started with design of use cases from data center workflows, followed by preparation of business rule and business processes to create business rule and business processes test scripts. Then run test data, business rule component inputs to generate test results. Finally, compare the results against use cases and objectives, then report the findings. As shown below, number of use cases were experimented, including the ability to add, modify, delete business rule component as a whole or separately, ability to initiate and terminate processes in workflow, ability to enable sequential and parallel processes flow patterns. A number of future research topics have been identified, but we will list down 4. First, currently in our model implementation, business processes consist of a sequence of decisions in specific moment in time, for example, completing a process step. In future, we could extend to include scenarios where changes can happen at any time within the process or outside the process. Second, although several algorithms have been developed, including change propagation and adaptation, further implementation of a series of algorithms for logical analysis of business rule could be implemented, leading to another application framework, for example, analyzing the logical vulnerability in digital banking. Third, the developed prototype does not consider low-level workflow activities such as sub-processes, sub-tasks, etc. Typically, a process may consist of several tasks to be performed before moving to another step or process. Therefore, subtasks or sub-processes will need to be considered to further improve the use of business rules in workflow. Fourth, currently, rules and components are presented in text format. The graphical visualization of business rule components and dependencies could be further improved by integration with graphical tools. Thank you for listening. Goodbye.